That's all right. We're going to start with an introduction anyway. So, hi everyone. Thanks for coming. My name's Graham. I work for Rakton, and we're going to talk about legacy systems and meshing those with Habitat systems to achieve the clickbait, which is the lift and shift. Who came for the lift and shift part? It works. So like I said, I work for a company called Rakton. Mostly what I do is architecture, chef and habitat stuff, automated deployment for a whole bunch of different people around the company. And my cat Nina, I have to show this every time. So lift and shift, what does it really mean? Or what does it mean to you? I think it's different for every person. For me, lift and shift is, and I'll explain exactly in a few slides, it's minimizing the effort required to get something to move or to mesh or talk with other systems. The motivation for us to containerize things has come around through upper management saying that containerization is the future. They say now, 2 years after it was going to be the future. As we start acquiring companies, there are lots of different architectures that we have to adopt and deal with, and consolidation is hard. So what Habitat allows us to do is to build those applications in a way that they're deployable on many different architectures, many different clouds, and on-premise as well. So given that consolidation is extremely hard to do in a large enterprise, sometimes moving towards flexibility rather than consolidation can be beneficial. You've got to find that middle ground though. Consolidation is a great target to be able to have, and Habitat gets you closer to that. So there's some myths and facts around lift and shift, and this is where I explain the clickbait. The myth would be that there are no changes at all required for an application to be able to move it from one place to another. What I'm going to show you though is how a very few amount of changes or just configuration changes are possible to get an application from your legacy environment slowly migrated over to your Habitat environment, to operate them both in parallel and work with configuration updates and how Habitat helps make that work. There is some work to do, and I think the hardest part around this kind of migration and doing a lift and shift with Habitat involved, the hardest part would be the Habitat plans. That being said, the Habitat plans are actually very straightforward. And I've got examples for these in a sample project I'll run you through. The other thing that's a difficult challenge, the lift and shift is achievable once you've got an environment to deploy into. So the setup of your Habitat supervisors, your supervisor ring, the resources you need to run the system is another piece that you'll need to address. So when I think about lifting and shifting, moving one application from one environment to another, and moving the legacy stuff forward with the rest of the architecture, it's thinking about what is the least disruptive route we can take to make sure it's a successful ongoing operation of the platform, application, or business, and a simplified upgrade path. Those two things for me make it a lift and shift. I don't have to re-architect the application. If there are some changes required, keeping it as minimal as possible. So I've seen a lot of demos in a lot of different conferences, and a lot around Habitat as well, where the demos are relatively trivial. I think this morning was a different example where we saw the National Parks app, which is a similar architecture to this, what I'm about to show you. But what I wanted to do was, at the end of this presentation, have a demo app that you could take and use and play with in a Habitat structure, something you can deploy a traditional database, link it to a Habitat deployed API, and then perhaps a traditionally deployed UI, mix it up and play with it yourself. So instead of deploying a Hello World application, I'll give you a quick run through of what I thought would be a fun idea. So I thought I'd take IRC, because IRC is fun and cool, a great way to communicate, and add a bit of CSS, because I haven't done front-end work in like 10 years. I thought that would be fun to learn again. Take some HTML. I think that's Webpack. Is that Webpack? I think that's Webpack. If anyone's dealt with it, I only just learned about this recently. It's a big pain in the bum. Front-end tooling is crazy. So I use Yarn for package management. I decided to learn React. That was an interesting experience. So that composes the front end, all of these pieces. So we're going to build an IRC-like tool. For the middleware, the API level, I decided to take my Go knowledge a little bit beyond the basics and build something that properly used channels. In addition to that, WebSockets in Go, not too complicated, but it was a fun experience. And then using a pub/sub model to listen to messages coming in and out of this IRC-inspired chat application. On the back end, I've decided to use Rethink Db. And so I think this qualifies as a three-tier application. It's non-trivial. It could exist across multiple different types of architecture. Rethink Db gives us real-time notifications of changes to the database that we can use in the UI, and that passes through Go, and Go handles the connections from the client. So blank slides are awesome. The first thing you need to do on a project, I think Dilbert taught us, is to come up with a name. So we've got like a real-time chat application. So I've decided to call it a scalable, low latency, asynchronous communication kit. Or Slack for short. So with Rethink DB at the back end and an API sitting in front of it, both of these tiers are scalable. The scaling strategy that you would use for Habitat and your traditional infrastructure could be quite similar. They may change, but what we're doing here is defining some contracts in the Habitat approach to show that very little effort is required to achieve the migration. The front end is an Nginx server that does the WebSocket proxy and HTML, CSS front end. And client connects to that. So with the application, and we'll run through it in just a bit, one of the key parts to migration, to doing a successful migration, I think, is in-service discovery. And so I'll go through a couple of examples of what I've found in the applications I've done to be successful models for service discovery and to breach that gap between your Habitat infrastructure and legacy infrastructure. So bidirectional would be the best goal. So what you can do with a lot of different services is one direction service discovery, or the way Chef does service discovery, I guess, is a good example of an initial step where it's based on an inventory and may or may not be up to date. The service discovery perspectives that you need to consider is inside the Habitat cluster. With an application that you've started to migrate into Habitat, how do you, from inside that cluster, find services that are not within that service ring? And the other side is outside the Habitat cluster, the legacy stuff. How do you address the stuff that's inside the Habitat service ring? There's two sides to think about it, and if you can achieve bidirectional service discovery, that's a great step towards making sure that you can lift and shift. So most of the applications that I work with are using this kind of structure, where I've got traditional apps, whether it be database, middleware, front end, whatever it be, it's indexed by a Chef server. And I think that anyone that's used a Chef server and is using a Chef search for service discovery quickly finds out that it's good up to a point. It's valid up until the last node run. Beyond that time, the inventory is actually considered out of date. So it's not a real-time service discovery. And in your recipes, you would do something like this. If you're deploying with Chef, you would do a search for your servers. For here, we're just searching based on tags because you shouldn't use roles, filtering the result. Once you've got the results back, you would throw that into some sort of template, and that would configure your application to communicate with those servers that you've searched for. Inside Habitat, it operates a little bit differently. And before I go on and explain this, I just want to see a show of hands. Who's used Habitat just at the basic level building a package? It's about half the room. So of those that have done that, have you deployed a service ring? Have you deployed a cluster? Put your hand up if you've done that. Okay, so half of that again, which I think is about right. So if you haven't built a package before, we're going to go through some of the commands that you would do primarily around deploying and configuring your application. Not so much building, but we can get into that if there's a bit of time at the end. Inside the Habitat supervisor ring, binding of applications is done like this. And we saw some examples this morning. You would load the service with hab service load, provide it your origin and your app, and then bind to a particular service. In this case, the blue is the alias for the service, and the green is the service name and service group. So that works well if you're inside the Habitat supervisor ring. But if you're not, then you've got problems. You need a way to bridge that gap. So we need some way to get from the supervisor ring to these other applications that are deployed traditionally and managed with Chef. So direction number one, Habitat needs to talk to the legacy nodes. And ideally, we could also talk from the legacy nodes across to the Habitat ones. That would allow us to mix and match and move parts of the application at a time without having to move everything all at once, without having to do a massive operation. The smaller the change, the smaller the risk involved in doing that change. So method one is a good example of how to do it, and it's the first example that I came across that worked well when I was doing a migration. Not the best example, but gives you an introduction to what's possible with these services. So to access legacy apps from Habitat, what we do is we deploy a special type of application. And I call this a service proxy. So it's a Habitat application that basically sits in a while loop and sleeps. That's what the service does. It doesn't do anything useful, but it's a service that can be loaded into Habitat and run. What you can do with that application when it's running is load a configuration into it. And once you've got configuration in the supervisor ring, that is addressable once bound by other applications. So in your service proxy, it would just hold configuration showing this is the address of my legacy MySQL server, or this is the address of my API server. Using that information, the Habitat deployed applications can then address those external IPs. To explain that a little bit more, I just want to talk quickly about what the Habitat producer and consumer contracts are like. So for any application that we're deploying, in this case, it's an application that requires a database and an API. On the database side, it requires a driver port. API, it requires a port and a secret. Now, in our example, if we had an app that was deployed like this, we would have a Habitat package that was deployed that was called Rethinkdb that would actually contain the runtime for Rethinkdb. When we started this application, it would actually run and publish the driver port that it's listening on. API would be, in our case, a Go application, publishing a port and a secret. By the way, publishing a secret is not a great idea. But what happens here is when we bind to a service, it links that application across to that service information. So application one is able to connect to Rethinkdb because we've told it to bind to a service that we're going to call database that actually is the Rethinkdb application. Those contracts match up, and so it's able to bind across. What we're doing is taking that model. So instead of deploying full applications, we can trim that down and provide the same contract. Instead of actually running Rethinkdb, instead of actually running an API, because we're migrating from legacy to Habitat, and we want the Habitat applications to still address the legacy deployed components, we deploy these service proxy wrappers. They present the same contract that is required for the application to bind to. So it provides a driver port, provides a port and a secret. And so it's able to bind to these proxy services. And these services contain configuration only. What you would do in this case is it's the same same command to load your service load my origin / my app, and when binding, you provide the name, which was database, and point it to your service proxy. The service proxy is just the name of that service. Default is the service group. I have an example of this that I will show you, but these are the commands that I've used to get it up and running. Once you've got the service proxy up, you can configure it by doing habconfig apply and passing in a configuration. In the case of a Rethinkdb, passing in Rethinkdb with a path to your host name for your legacy host and the port that it's on makes that configuration available in the service ring. So any application that's binding to a database contract and is pointing to this is able to use that configuration information in the Habitat applications. Okay. So it's got a few points and a few problems. It's a one-way bind. You're only able to communicate from Habitat to the legacy side. You're not able to do discovery the other way around. You do have direct control of the service registration, so that can be a pro and a con. You can actually give it a specific IP that you want to connect to, rather than a random IP from a pool. It is, though, it's inflexible in terms of change. If your legacy infrastructure changes, you're going to have to manually update that service proxy. So the next thing that I came across was integrating with console to do some service discovery. Initially to solve the inflexibility of Habitat to legacy, but it actually solves a few more problems than I expected. So the first step to this was taking the traditional infrastructure and simply adding console to it, creating a new console cluster and registering all of the applications I needed as console services. In addition to that, deploying into Habitat a console node that registers the services that it is bound to. So once you connect these two, you've immediately got yourself a communication layer, a service discovery layer that breaches the gap between the Habitat supervisor ring and your traditional infrastructure. Now, console is almost real-time in its service discovery, its service publishing information. If an application goes offline in your legacy infrastructure and you've got your checks configured correctly, it will no longer be served as a result from your console service checks. So in the Habitat structure, the console deployment can be single node or multi-node. For simplicity, and because this should be a short-term migration structure, I suggest just doing a single node for console, purely for simple service discovery over a short period. So what your console cluster would look like this, and this is just one approach, and this is one that's worked for me, is I actually separate the data centers. So I've got a Habitat data center and I've got a Chef data center, right? And this represents, each data center represents where those nodes are for those services. So while I have a database deployed in Habitat, I have a database deployed in Legacy, I can address them separately and I can group those and communicate with them differently under different circumstances because they've been grouped. So the service discovery when you're using console looks the same. Sorry. When you're binding to the service, if anyone's used Habitat, you'll see the templating structure. You're binding to the database, getting the first one and just using the system IP, and pulling from the configuration the driver port. So the configuration looks the same. And what you get back when you're using the console DNS service, if you've separated into separate data centers, is you'll see something like database.service.habitat.console and .chef.console for the Chef deployed stuff. So using the DNS-based approach, injecting that configuration, it's a better solution, but it's not ideal. There's a separate evolution to this that happened by mistake that I'll take you through next. Sorry, just 1 second. Okay. So the DNS into, sorry. Slide order is a little bit off. So one thing you may not have seen in the habitat plans is that binds are optional. And at first this didn't make a lot of sense to me. Like, why would you have a bind but it not be mandatory? But the reason why you would have this is, for one, this particular migration path. What you can do is, if you've got an application configuration like this, config.yaml for some sort of application, you can specify static values that would be console looked up DNS entries. So these match, minus the data center here, these match the services that we've deployed with console, and these would do DNS lookups to return the host that you've deployed. What you can do, and this is just for the database example, is query as to whether or not binds are actually present. So if binds are present for the database, actually use the bind information. This one's pulling out the first server from the database binds and using the IP. If there are no binds present, then use the console lookup information. So it's a very, very simple example, but what this is showing is that we're using underlying all of the nodes. We're using DNS served by console, so we're able to use a real-time service discovery across all of the nodes. But then if we decide to bind specifically to Habitat, if we're starting to improve or increase the migration rate, we're getting a lot more nodes over, and we don't need the service discovery covering both parts of the infrastructure anymore. We can start directly binding with Habitat. What that direct binding will do is use only the Habitat nodes and bypass this static configuration. And this is just the API example. If there's an API bind available, use that. Otherwise, use the console host. So, there are always special Snowflake examples of applications everywhere. Everyone thinks that their application is a Snowflake, I think. I think no matter what application you've got, there is a way to mix technologies. And I've talked a lot about console specifically, just because that's the technology I've chosen in this particular case. But there are other techniques you can use. Mixing those with Habitat is just a matter of getting their configuration right. And so I want to take you through a little bit of code example right now. And you get to look at this while I get my code editor up. So this is a console proxy that was built specifically for this example. And this console proxy will be available on GitHub at the end of the talk, along with the application that was built for this demo. So what we've done here is simply using, so you'll see the package dependencies. We have a BusyBox static, but we rely mostly on the core/console. So we're wrapping the console plan to provide just our custom configuration for it. We're exporting and exposing port information just for console. So this is actually a direct copy and paste from the console plan, just so that we can get those ports exposed and we can bind to those if necessary. But the core of this is providing these optional binds. So we require a database that should have a driver port, an API should have a port. I've also got the UI in there if you want to have the UI legacy or in Habitat. But you'll see the rest of the plan is just return 0 for all the build steps. And this is what I think, and hopefully they're still calling a configuration plan. It's just wrapping configuration, skipping all the build steps, and including the binary you need to run. In our run hook, it's, again, almost copy and paste from the console plan. Simply running console, rendering the configuration that we need, which is here. So when I start this console proxy, I need to bind it to these optional binds. We have database, API, and UI. And when database is bound, this service configuration will be generated, which turns into a service registration in console. It makes that available for search through console and via the DNS interface. So it's just pulling the first database IP and pulling the port from that as well. And you'll see the same in the API. So this is the approach that mixes the two. The simple service configuration proxy that we looked at, the simple service proxy is really handy if you're just going to have one-way communication. If you're deploying your Habitat nodes, you've got a load balancer perhaps at the top, and you just still need to register or talk to a legacy database. And I think that's the best example. For me, it was Cassandra database. I was super, super scared about making Cassandra work in Habitat. No longer scared of that. It's not a problem. But having that database and keeping that stateful information in a place where I know it's safe, it's secure, it runs well, and we've already optimized it was excellent. I could run all the cool stuff in Habitat but link across to the old database. Using just the service proxy was a good way to go about it, which I'll show you now. So this is public and available for anyone to use, and it was actually published based on a question that came out of the Habitat community Slack. How do I bind to, or how do I talk to legacy infrastructure? And through some help from the Habitat engineering team, this plan came about, or this approach. So in our plan SH, I'll show you the bottom first, all of the build steps are empty. We're not wrapping anything in particular, but there are no build steps. This is not actually going to run anything useful. It's just there so that a service is running and has an associated configuration available. In this case, I've got, in the package exports, I've got a MySQL server, Elasticsearch, and RabbitMQ. Those are the services that I want to expose. And to expose them properly, what I need to do is provide the host, the port, the username, and maybe the password. For Elasticsearch, it's just the URI. RabbitMQ, you've got the queue as well in there. But what this means is these pieces of information are available for anyone to bind to and use, consume on the Habitat side. All we require for this plan is BusyBox static, and that's just so that in the run loop, we can actually do something to keep the service running. So this is actually like way more complicated than it needs to be. It echoes out that bind service is starting, goes into an infinite loop, and I just need to see that it's running. So I've got a configurable sleep time, and I have it output beep and boop every now and then, just so that I know that it's running. This is all this needs to do so that the configuration can live in the Habitat service ring, and when we can bind to that. You can actually take this, and all you would need to change for your service is in the plan SH, these package exports just need to match what your configuration needs to be. The only other piece of information in here is a default TOML. So this is a default configuration that is launched when this service is launched. So by default, I've got mysql.example.com. So step one would be to launch this service. Step two would be to inject my legacy information into there. Here's the address of the MySQL server on my legacy infrastructure. This is the port it's on. Again, maybe password is not a great idea. Elasticsearch URI. Once that information is in the service ring, you can bind to it and use it and consume it as if it was a Habitat deployed service. As long as you can communicate with it over the network, Habitat doesn't need to know. Okay. Now the demo application that I did for this is, I've got cookbooks for it to deploy it onto legacy infrastructure, deploying the application with Chef. I've also got the whole thing planned with Habitat, but the point of the talk being migration, and I will just put up one more slide before we go. It doesn't actually have the migration steps, and when I tried to launch the infrastructure today on a provider I won't name, the instances weren't functioning. But what I can do is I can show you through the demo, or I can start taking some questions on the migration approach that we've done, the success and failure that we've had, anything you like. There's some links down the bottom here for the API and the UI that was done. And I might just run you through it very quickly, just launching this service on Habitat. So I'm only doing one thing a little bit different here from entering the studio. I'm not sure if you've seen this or not, but when you're entering the studio, you are just entering a Docker container. That's all you're doing. What you can do is provide some options, which are just Docker options, really, for the HabDocker ops, to tell it to, in this case, forward some ports. So I've added, 20,000 to every port number, just to make sure that I've got some unique ports so I can access it. And then I'm telling it to, to enter the studio. And just so the guys at the back can read. Now the first service I use is Rethinkdb. There's nothing special about the database, nothing specific to my application. So in this case, I just use the core Rethinkdb. And crossing my fingers for the conference Wi-Fi. So this is pulling down from the public builder. And you see it's pulling down all of its dependencies. As long as this wasn't updated in the last 12 hours, it will be exactly what I've been building on. So it says it was successfully loaded, and I can see server ready in the supervisor logs. The next thing I've got is the API. And I've put that, again, on the public builder, but under my own origin. And I've called it Slacker API. This one needs to bind to a database. So I'll put --bind database, and we want to bind to rethinkdb.default. And I'm just watching the supervisor logs. I can see this is the output from my application starting up. It's listening on port 4000. And the last component is the API. Sorry, the UI. And this one needs to bind to the API. And I can see the service was started. So what I'm able to do here is just quickly test locally. This is my full stack. I've got a database running, I've got the API running, and the UI running. What's super cool about this is it took me 2 weeks, I think, to learn Yarn properly, because it's really complicated. It's really terrible. My dependency tree for running a simple static HTML website was like megabytes. It shouldn't be a megabyte, right? It's static HTML. Anyway, so what this is, if you want to get someone set up and running with an application that you've got, and it uses something like Yarn and a massive complex tree, you've got a package that's already running. People can just run it. So your developers can just run this locally. They've got a package ready to go. They don't have to worry about that, that complexity. So I've forwarded it on port 20,080. And you can see we've got our completely unique IRC-inspired real-time chat application. That's the room. Something is going on. Yeah. So this is the example I used to migrate from legacy to Habitat and build the service bindings between them. With the service proxy one way, console DNS, and the console cluster bridging across the two. And I just thought it would be fun to learn HTML in this day and age and build a completely unique chat application. All right, I am around for the next couple of days. I'd love to answer any questions you've got on Habitat in general, migration and the real migration that we did. I couldn't show you the actual application I did migration for, or any discussions around the talk in general.